This video goes with Kuta handout number 3, and basically it's just a tutorial on how to solve systems of equations using both the substitution method and the elimination method. Starting with the substitution method for problem number 1, we have two equations in slope-intercept form. One says y equals 4x minus 4. The other says y equals a negative 2x plus 8. And if we were to graph these two equations, they would intersect at a certain point in the graph, and that would be the solution to the systems of equations, is that point of intersection. We've done a unit on graphing, but this is using just an algebraic method to find that point of intersection, and it's called substitution. If we say y equals 4x minus 4, if that's what really y equals, then we're going to substitute it in place of y in the second equation, and we will get this. We will get 4x minus 4 equals a negative 2x plus 8. And if I just solve this for x, I can find my x-coordinate of the point of intersection. And remember, we need an x-coordinate and a y-coordinate to find that point of intersection. So I'm going to go ahead and solve this for x. I'm going to draw a dotted line down here to separate the two parts of the equation, the two sides, and I'm trying to get all the x's on one side, so I'm going to do this. I think I'm going to add a positive 2x to this side. I do the same thing on the other side of the line, add a positive 2x, and then my sum line to see what happens. I get this, I get 6x minus 4 on the left-hand side of the equation, and because these cancel, the only thing left is a positive 8. And now if I continue to solve this equation for x, I would add 4 to both sides. And once again, when I do the sum line, these cancel, and now I have 6x equals 12. And if I continue to solve, to get x all by itself, I would divide by 6, divide by 6, and so x would equal 2. So I found my x-coordinate. It is a positive 2. But now I just need to find the y-coordinate. So if I say x is 2, I could go back to my two original equations in slope-intercept form. And if I just replace the x with 2, and it doesn't matter which equation I decide to do, and solve for y. Here I get 4 times 2 is 8. 8 minus 4 equals 4. And if I solve the second equation, I get a negative 2 times 2, which is a negative 4, and negative 4 plus 8 is a positive 4. So in both cases, my y-coordinate is a positive 4. We've done this in class, so this is just basically a review. But on the second step, we just started this today, this is solving systems of equations by the elimination method. And so this is a little bit different, sometimes a little bit harder. I get rid of my recording symbol there. And basically, what I would like to happen is something to eliminate. That's why it gives this nickname, the elimination method. So I'm just going to go ahead and move problem number 11 over to the side here. And here I get a negative 9x minus 9y. All of this equals a negative 27. And my other equation is a negative 3x plus 9y. And all of this equals a negative 21. If I decide to use this method, I have to have my equations in this form, x and y on the same side of the equal sign or the same side of the equation. And of course, when I just sum these together, something should eliminate. So negative 9x and a negative 3x becomes a negative 12x. My negative 9y and positive 9y cancel, they eliminate. And so that's going to equal a negative 48. And if I continue to solve for x, I would divide by negative 12, divide by negative 12. And my x would equal a positive 4. So I found my x-coordinate. My x-coordinate is a positive 4, so remember I need that ordered pair. And so I just said x is a positive 4. Now I need to solve for y. And so I must pick one of my original equations. I'm going to take the top one, a negative 9, but in place of x I'm going to put a positive 4 minus 9y. All of this equals a negative 27. So I just substituted x with a positive 4. If I continue to solve, I get a negative 36. Oops, minus 9y. And all of this equals a negative 27. And if I go ahead and try to solve here, I'm going to add 36 to both sides. Add 36 and add 36. And when I do my sum line, these cancel and I get a negative 9y. equals a positive 9. And if I continue to solve, when I divide by negative 9 and divide by negative 9, I get y equals a negative 1. So my y coordinate is a negative 1. I think I'll do one more example here. And the example that I'm going to do will probably be problem number 13. And then problem number 13, we'll do the same thing. Just go ahead and line up the two equations and see if something eliminates, cancels. So in problem number 13, I get a negative x minus 4y. All of this equals a negative 9. And my second equation is 9x and plus 4y. All of this equals a negative 15. And if I sum these together, I hope something will eliminate. When I put the x's together, I get a positive 8x. My y's eliminate. When I put this together, I get a negative 24. If I continue to solve for x, I divide by 8, divide by 8, I get x equals a negative 3. And now I need to substitute that x into one of the original equations. And I'm going to pick the bottom one. And here I have 9 times 3 plus 4y. All of this equals a negative 15. And now I'm going to solve for y. I get 27 plus 4y. All of this equals a negative 15. If I continue to solve, minus 27 on both sides of the equation. These cancel, and now I get 4y equals a negative 42. And if I divide by, gotta use my math correctly here. Something doesn't look right. Oh, I can see my mistake. I'm substituting with a negative 3, which is going to make this now a negative 27, which means this is going to be a positive 27. This is going to be a positive 27. Let's see if I can clean this up a little bit. Now if I put this together, a negative 15 and a positive 27 together, if I put that together, I'm getting a positive 12. Divide by 4, divide by 4, I'm getting y equals a positive 3. Good point not to sit there and miss a sign, so my point of intersection is a negative 3, comma a positive 3 for the point of intersection. Hopefully this will help out for those students working tonight. Let's see if I can shut down my recorder here real quick.